All right, Algebra 1 students, this is page 9. So I'm trying to solve my system. I need to solve one of these variables first. So I'm going to take my first equation and I'm going to solve it for x. What I'm going to do is I'm going to take 3y away from both sides. This is a literal equation, so I'm solving for one variable. So 3x is left over. 3y minus 3y is 0. And we're left with 6 minus 3y. Not like terms, so I can't put them together. Then I need to get x by itself, so I'm going to divide both sides by 3. So this divided by 3 and everything on this side divided by 3. So x equals 6 divided by 3 is 2. 3 divided by 3 is 1, so minus 1y, or just y. Now that I have x by itself, I can substitute this x in for this x in equation 2. So I've got 3, and I'm putting in 2 minus y instead of x. Still have plus 2y equals 4. Okay, now I need to distribute. So 3 times 2 is 6. 3 times negative y is negative 3y plus 2y equals 4. I distributed, now I need to combine like terms. So negative 3y plus 2y is negative 1y equals 4. Now I just solve for y. So I'm going to take 6 away from both sides. So 6 minus 6 is 0. I still have negative 1y. And 4 minus 6 is negative 2. Then I need to divide both sides by negative 1. So y equals, well, negative 2 divided by negative 1 is positive 2. Y equals 2. And then I substitute this y equals 2 back into either original equation. Doesn't matter. So I'm running out of space. I'm going to do it over here. I'm going to use equation 1. So I have 3x plus 3. And instead of y, I'm going to substitute 2 equals 6. Well, 3 times 2 is 6. So 3x plus 6 equals 6. Then I need to solve for x, so I'm going to subtract 6 from both sides. Well, 6 minus 6 is 0. 6 minus 6 is 0. I have 3x equals 0. I divide both sides by 3. X equals 0. So my solution is 0, 2, right? 0 for my x, 2 for my y. I write it as a point, and I am done. Now, remember solving equations that we have these special situations? Sometimes we get it and both of the variables cancel and we get a number equals a number. If it's a true equation, then this is that infinitely many solutions. So essentially, by the graph, these is the same graph, right? They're on top of each other. On this one, we have parallel lines, right? This is where the variables cancel and we get an untrue statement. So this is when they're parallel and there will be no solution. It will never cross. Okay, so here's 2. So what I'm going to do is I'm going to make my substitution for y into equation 2. So I have 12x minus 3 times 4x minus 2 equals negative 6. I need to distribute. So negative 3 times 4 and negative 3 times negative 2. So 12x, negative 3 times 4 is negative 12x. And negative 3 times negative 2, negative times a negative, positive. 3 times 2 is 6. So I distributed. Now I need to combine like terms. 12 minus 12 is 0, so that canceled. I get 6 equals -6. That's not true. So this is one of those no solutions. So basically, these two lines are parallel. Now this one, so we have y solved, so I'm going to substitute 3x minus 11 in for y. So 3x minus 11, and then the rest of the equation, minus 3x equals -13. I combine like terms, so 3x minus 3x cancels and give us 0x, so I get -11 equals -13. This is not true as well, so this is no solution. So sometimes you're going to get no solution. Sometimes you will also get this infinitely many solutions if it turns out to be true. This last one was pretty close, but it's not. It has to be exactly the same.